All right, so for this video, we're going to finish up lesson 1. So we're going to talk about adding, subtracting rational expressions, and then working with the least common multiple method and reducing complex rational expressions. So adding and subtracting rationals are the same as rational numbers. So if you have a common denominator already, all you're going to do is add or subtract their numerators. So for my first one, I have 2x squared minus 4 over 2x plus 5 plus x plus 3 over 2x plus 5. So again, since I have that common denominator of 2x plus 5, I can go ahead and just rewrite this as one rational expression. So I can write this as 2x squared minus 4 plus the quantity of x plus 3 all over 2x plus 5. And again, it already gave us that excluded value of negative 5 halves because my denominator cannot be equal to 0. And so now all that I'm going to do is I'm going to simplify my numerator by combining my like terms. So when I do that, that gets me 2x squared plus x minus 1 over 2x plus 5. And now what I need to ask myself is, can I simplify that numerator? So I can factor that. So the two numbers, if I use AC, are going to be positive 2 and negative 1. So again, if I have 2x squared plus x minus 1, and again, if I do that AC method, I can split that middle term to be 2x squared plus 2x minus 1, and then I'm going to group. So I'm going to factor out a 2x, which leaves me x plus 1, and then factor out a negative 1 to give me that x plus 1 common binomial. So I know that this is now factoring to 2x minus 1 times x plus 1. So I'm going to rewrite that as my numerator. So I have 2x minus 1 times x plus 1 over 2x plus 5. And I look, there's nothing that I can cancel between numerator and denominator, so I am finished up. Okay. Going on to the next one, I have x over x minus 3 minus 3x plus 2 over x minus 3. So again, I have this common denominator. So I can rewrite this as one rational expression. So x minus the quantity of 3x plus 2 all over x minus 3. The only thing to watch for when you're subtracting rationals is to make sure you distribute a negative if you have to. So I want to make sure that I distribute that negative to both. So this gets me x minus 3x minus 2 over x minus 3. And I can combine x minus 3x, which is going to give me negative 2x minus 2 over x minus 3. And then I look at my numerator, see if I can factor that down at all. And I can factor out a negative 2. So factor out negative 2, which gives me x plus 1 divided by x minus 3. Okay. Now, so again, these two, they weren't too bad because we had the same denominator. Now, if we don't have the same denominator between the two rational expressions, we need to multiply each rational expression by the other denominator to get what we call a common denominator. So that way what we do is exactly what we just did. So I have x minus 3 over x plus 4, and I have that added to x over x minus 2. So again, I see I can't just go ahead and add these two rational expressions because I don't have that common denominator. So what I'm going to do is I'm going to multiply the first rational expression by the denominator of the other to the numerator and the denominator. So I'm going to multiply this by x minus 2 over x minus 2. And I'm going to multiply the second rational expression by the other denominator. So I'm going to multiply this by x plus 4 over x plus 4. And again, what this does is this gets me a common denominator of x minus 2 times x plus 4. And we are going to leave it in factored form, not distribute the binomial to the other. And so now what I need to do is I need to go ahead and I need to multiply these numerators. So this would be just, again, foiling. So when I FOIL this out, I'm going to get x squared minus 3x minus 2x is minus 5x plus 6. Plus then, again, I have that common denominator of x minus 2 times x plus 4. And then I have x times x plus 4, so that's going to be x squared plus 4x. And now since I have that common denominator right here, again, that's why we multiply by the other denominators to get that common denominator. So now I can just write these as 1. So I get x squared minus 5x plus 6 plus x squared plus 4x all over that common denominator of x minus 2 times x plus 4. And then I look in my numerator and I ask myself, can I simplify? And I can. So x squared plus x squared gets me 2x squared. Negative 5x and 4x gets me a negative x plus 6 divided by x minus 2 times x plus 4. Okay, and then again, last thing I need to see is can I factor the numerator? And this quadratic is not factorable, so this is as simple as we can get these rational expressions. Okay, all right, going ahead on to the next one. I have x squared over x squared minus 4 minus 1 over x. And I have those excluded values. So you do always want to start. It's also easy if you have a denominator that can be factored, factor that. So I have x squared over x minus 2 times x plus 2 minus 1 over x. So what I'm going to do is I'm going to multiply the other denominator again. So I'm going to multiply the first by x over x. And then the second one, I'm going to multiply by x minus 2 times x plus 2. You are going to see x squared minus 4 multiplying by that is completely okay. So now I have this common denominator of x times x squared minus 4. Again, I have x times x squared minus 4. So now when I multiply my numerators, x times x squared gets me x cubed. And then 1 times x squared minus 4 gets me, again, that x squared minus 4. Okay. So now I have that common denominator, so I can write this as one rational expression. So this gives me x cubed minus the quantity of x squared minus 4 over x. And now here's where I'm going to want to factor that denominator. So x squared minus 4, again, like we said, factors into x plus 2 times x minus 2 because it's a difference of squares. And now we want to make sure that we're watching our signs, so we distribute that negative to both of those terms. So that is going to give me x cubed minus x squared plus 4 over x times x plus 2 times x minus 2. And I cannot factor the numerator. There's nothing that I can cancel out, so I am done. Okay, now we're going to talk about the least common multiple method. So we kind of did this already, but now it's just if we have something that can be factored, okay? So the least common multiple method, step one is to completely factor the polynomial in the denominator of each rational. And then it's identifying the LCM, which is the product of each of the factors that is raised to a power equal to the greatest number of times that the factor occurs in the polynomials. Then we're going to write each expression using that LCM and then add or subtract like we just did. So first off, finding the LCM of a pair of polynomials. So I have these two polynomials, x times x minus 1 squared times x plus 1, and 4 times x minus 1 times x plus 1 cubed. So to find the LCM, what you do is you compare the two polynomials, and anything that is a factor in either polynomial is a part of the LCM. And if that factor shows up in both or all of the polynomials that you're working with, you look for the biggest degree. The biggest degree is what becomes part of the LCM, okay? So what I do is I take a look. In the green polynomial on the right, I have a whole number of 4. And then I take a look at the first polynomial that's in blue, and I have that x is a factor, so that's also part of the LCM. And now I have x minus 1 as a factor. That is in both polynomials. So what I do is I look at the powers, and I pick the greatest power. So I have that factor of x minus 1. It's squared in the first polynomial. It's to the first and the second. So in the LCM, it's x minus 1 squared. And then similarly, comparing the two, I have x plus 1 as a factor. So it's to the first power in the first polynomial, to the third power in the second. So again, I want the greatest power. So it's going to be x plus 1 cubed. And that is going to be the LCM. Okay. So now, actually adding and subtracting with this. So again, step one is always to completely factor. So my first rational expression, I have x over x squared plus 3x plus 2. So that denominator can factor to x plus 2 times x plus 1. Plus now 2x minus 3 over x squared minus 1. So that we see as a difference of squares. So this is going to be x minus 1 times x plus 1. So now what we want to do is we want to identify what is the least common denominator, just like the least common multiple, okay? So I'm going to compare the two denominators of my rational expressions. and I want to find the least common multiple, which in this case, again, since we're working with rationals, is called the least common denominator. So I see in my first polynomial, I have x plus 2, and I have an x plus 1. And now I'm going to look at the second polynomial in my second rational expression denominator, and I am missing the x minus 1 factor. So that is my LCD. And again, all of these factors are raised to the power of 1, so I don't have to worry about taking the largest degree. Okay. So now what I'm going to do is I still have this. So I have x over x plus 2 times x plus 1 plus 2x minus 3 over x minus 1x plus 1. So what I'm going to do is I look at the LCD and I ask myself which of those factors is missing in my denominator. And then just like we did on the last page, I'm going to multiply that factor to the numerator and the denominator. So in my first rational expression, I'm missing x minus 1. So I'm going to multiply x minus 1 to both. And then in my second rational expression, I'm missing x plus 2. So I'm going to multiply x plus 2 to both of them. So again, what this does is this gets me the LCD as my denominator. So x minus 1 times x plus 1 times x plus 2. Again, order doesn't matter. And then when I multiply those numerators, x times x minus 1, this is going to give me x squared minus x. And I have that LCD again. So I have x minus 1 times x plus 1 times x plus 2. And then when I go ahead and multiply my numerators, again, this is going to be foiling. So this is going to get me 2x squared plus 4x minus 3x gets me plus x. And then negative 3 plus times positive 2 is a positive 6. And so now what I can do, since again I have that shared denominator, I can just go ahead and add their numerators. So this is going to give me x squared minus x plus 2x squared plus x plus 6. All over that common denominator of x minus 1, x plus 1, x plus 2. And then I'm going to go ahead and simplify that numerator. So combining my like terms, I have x squared plus 2x squared gets me 3x squared. Negative x plus x cancels out, and that leaves me plus 6. All over x minus 1 times x plus 1 times x plus 2. And then I look in my numerator. I can factor out a 3, so we do want to make sure that we do that. So now my final simplified answer, factoring that 3 out, gets me x squared plus 2. Typo. This should be negative 6. So that should also be minus 6 plus x minus 6. Sorry about that. So it's going to give me 3 times x squared minus 2. There we go. Over x minus 1, x plus 1, and then x plus 2. So that is that fully simplified down. Okay. All right, go ahead on to the next one. So I want to factor again both of my denominators. So I have 3, and then I can factor out an x. So that leaves me x plus 1 minus x plus 4 divided by x squared plus 2x plus 1 is a perfect square trinomial. So this is x plus 1 squared. So now, I need to find my LCD. So I see that I have x in the first, and I have x plus 1 in the first. There is the factor of x plus 1 in the second as well, and since its degree is bigger, I need to square that. So my LCD is x times x plus 1 squared. So rewriting this, 3x times x plus 1 minus x plus 4 over x plus 1 squared. I need to go, and I need to ask myself again what's missing. So in the first rational expression, I'm missing the squared part of the x plus 1. So I'm going to multiply numerator and denominator by x plus 1. And then in the second rational expression, I'm missing x. So I'm going to multiply that to my numerator and my denominator. So now I have that common denominator of x times x plus 1 squared. And multiply my numerators, 3 times x plus 1 gets me 3x plus 3. Minus, again, that shared denominator of x times x plus 1 squared. So x times x plus 4 gets me x squared plus 4x. Okay. Now I'm going to rewrite this. Get a little more space. So this is going to be writing this as 3x plus 3 minus the quantity of x squared plus 4x. All over that the LCD, x times x plus 1 squared. We'll want to watch, make sure that we distribute that negative. So when I combine my like terms, this gets me 3x minus 4x and negative x squared and positive 3. Starting in descending order gets me negative x squared. Again, 3x minus 4x is minus x, and then leaving me a plus 3 over that LCD, x times x plus 1 squared. There's nothing that I can factor in the numerator. There's nothing that I can cancel out, so we are finished up. All right, last thing, reducing complex rational expressions. So a complex rational expression is when sums and or differences of rational expressions are in the numerator and denominator of a quotient. So I want you to think it's a rational inside of a rational. So what we're going to do to simplify these is treat the numerator and denominator separate. We're going to simplify both of them and then simplify the resulting expression, which is going to be the division of two rational expressions. So the first one, I have 1/2 plus 3 over x divided by x plus 3 over 4, and I have my excluded values there. So again, what you want to do is start with the numerator and simplify the numerator. So I have 1/2 plus 3 over x. So I know that the LCD of those two is 2x, which is exactly what we just talked about. So I'm going to multiply, again, just like I did to get that common denominator. So the first rational expression I need to multiply by x over x. The second I need to multiply by 2 over 2 to get that common denominator. And again, this is all over x plus 3 over 4. So now when I go, I again have that common denominator 2x, and I multiply my numerators. X times 1 is x, 3 times 2 is 6. And this is all over x plus 3 over 4. So now I look at my denominator. I ask, can I simplify that? It's already simplified. It's one rational expression. So now what I'm going to do is I'm going to combine those two rationals in my numerator. So I can write this as x plus 6 divided by 2x all over x plus 3 over 4. Now this is, again, just division. So remember, division of rationals is really multiplying by the reciprocal of the denominator. So this is the same as x plus 6 divided by 2x times 4 over x plus 3. And now we're just going to go ahead and multiply. So you get 4 times x plus 6 divided by 2x times x plus 3. And then I want to see, is there anything that I can simplify between numerator and denominator? 4 divided by 2 I can simplify as 2 over 1. So my final simplified expression is 2 times x plus 6 divided by x times x plus 3. All right, going ahead on to the next one. X squared over x minus 4 plus 2, all over 2x minus 2 over x minus 1. So let's start off with that numerator. X squared over x minus 4 plus 2. So comparing these two expressions, the LCD, again, remember a whole number has a denominator really of just 1. So the LCD here is x minus 4. So since I have that LCD already in my first expression, I don't need to multiply anything to it. But in the second one, I'm going to need to multiply the numerator and denominator by x minus 4 to get that common denominator. And so then I can go ahead, simplify that. So this gets me x squared over x minus 4 plus 2 times x minus 4 is going to be 2x minus 8 over, again, that's the common denominator of x minus 4. Okay. Now remember, this is all over a denominator as well, so 2x minus 2 over x minus 1. So similar to the numerator, that first expression has the common denominator because if we compare the two, 1 and x, the least common denominator is going to be x. So I need to multiply that second rational expression by x over x. So I can go ahead and simplify that now. So this is going to give me all over, so I got 2x minus 2 over x minus 1 times x is x over x. And so now we're going to go ahead and simplify, just do that addition and subtraction as 1. So this is going to give me x squared plus 2x minus 8 divided by x minus 4, all divided by 2x minus 2 minus x. So 2x minus x is x minus 2 over x. And again, this is now dividing, so it's multiplying by the reciprocal. So I get x squared plus 2x minus 8 over x minus 4 times x over x minus 2. And I look, I can factor that numerator of my first rational expression. So this is going to factor into x plus 4 times x minus 2 over x minus 4 times x over x minus 2. And now I look, I can cancel out the x minus 2's. So this leaves me now with my final answer of x times x plus 4 over x minus 4. And that's that fully simplified down. Remember, we do not redistribute the x. Okay. Last one, application. So an electrical circuit contains two resistors connected in parallel. If the resistance of each is R1 and R2 ohms respectively, their combined resistance is given by R equals 1 over R1 plus 1 over divided by R2. Step 1, it says to express R as a rational expression. And what this means, express as a rational expression, is to write it as one fully simplified rational expression. So let's start there. So I have my resistance is 1 over R1 plus 1 over R2. So this is a complex rational expression, very similar to what we just took care of. So I look at my numerator, 1, can't really simplify that much further. So I'm going to look at my denominator now. So the LCD between these two rational expressions is R1, R2. So I'm going to need to ask myself what's missing from each to get that common denominator and multiply by it. So the first one, I'm missing R2, so I need to multiply numerator and denominator by R2. And then in the second rational expression, I'm missing R1, so I'm going to multiply both by R1. So then simplifying that out, this gets me 1 over R2 over R2 R1 plus 1 times R1 is R1 divided by R2 R1. And again, simplifying that denominator, since I have that common denominator, I can combine. So this is going to give me 1 over R2 plus R1 over R2 R1. And I now have this rational division again. But remember, 1 over something is really just the reciprocal. So if you were to do the multiplication of the reciprocal, it's just going to be the reciprocal of the rational in the denominator. So I get that my R here is R2 R1 divided by R2 plus R1. And that is that written as one single rational expression. So now the last part, it says evaluate the rational expression if R1 is 6 ohms and R2 is 10 ohms. So all I'm going to do is I'm going to substitute those values in. So I know that R1 is 6 and I know that R2 is 10 ohms. So substituting those in, I get that my R is 10 times 6 over 10 plus 6. So this is going to give me 60 over 16, which I can reduce if I divide by 4. This is going to give me 15 over 4 ohms is going to be the resistance on that.